All right, so in this section, we're going to talk about pairs of angles. And of course, if we have a pair, that means we have two. So adjacent angles. Adjacent angles are two angles that share a common vertex and side, but have no common interior points. So here, for angles 5 and 6, we have a common vertex. Here, we have a common side and no interior points. What does that look like? So let's come over here and color in all the interior portion. So we'll do angle 5 in green. And if I can stay within the lines, we will see that I can stretch these out forever, but the green and pink will never mix. So we can say that angle 5 and angle 6 are adjacent angles, whereas angle 7 and 8 are non-adjacent. They do not have a common vertex, they do not have a common side. And these two don't have common interior points, but all three things need to be true, so they are non-adjacent. So complementary angles. Complementary angles are two angles whose measures have a sum of 90 degrees. They do not have to be adjacent. Any two angles that add up to 90 degrees are complementary. So if I look over here in my examples, I got my little box, which means a right angle, which is 90 degrees. So angle 1 and angle 2 are complementary. And then angle A and angle B, well, 20 plus 70 is 90. So angle A and angle B are complementary. Now, similarly, we have supplementary angles. And supplementary angles are different from complementary angles in their measures. The measure of the two angles that are supplementary is 180 degrees. Once again, do not have to be adjacent. But as we recall from an earlier lesson, a straight line or a straight angle has 180 degrees, so any two angles that make a straight line have to be complementary. So angle 3 and angle 4 are supplementary. And I said complementary just a second ago. Angle C and angle D, well, 115 plus 65 adds up to 180, so they are also supplementary. And the way I remember it, C comes before S in the alphabet, and 90 comes before 180 when I'm counting on the number line. So complementary 90, supplementary 180. So let's do a couple examples and see how it's going to work for us. One is the complement of 2. And complementary means they add up to 90 degrees, so the measure of angle 1 plus the measure of angle 2 equals 90. Well, 1 is 62, so I can substitute. So 62 plus the measure of angle 2 equals 90. And I can subtract 62 from both sides to get the measure of angle 2 all by itself. And so the measure of angle 2 is going to equal 90 minus 62, or 28 degrees. Let's do a supplement now. 3 is a supplement of angle 4, so that means their measures add up to 180 degrees. And the measure of angle 4 is 47, so I can substitute that. So the angle of measure 3 plus 47 equals 180. Subtract 47 from both sides, and I get the measure of angle 3 equals 133 degrees. All right. 5 is a complement of 6. In fact, why don't you pause the video, attempt 5 is a complement of 6, and 7 is a supplement of 8. Restart, and we'll see how you did. All right, 5 is a complement of 6, means the measure of angle 5 plus the measure of angle 6. Angle 6 equals 90 degrees. 6 is 53, so I can substitute that. So the measure of angle 5 plus 53 equals 90. And subtract 53 from both sides. We get the measure of angle 5 equals 37 degrees. All right, last one on this page. Angle 7 is a supplement of angle 8, which means the measure of angle 7 plus the measure of angle 8 equals 180 degrees. Measure of 7 is 29, so I can substitute in 29. And I subtract 29 from both sides, and I get the measure of angle 8 equals 151 degrees. And that's complements and supplements in a nutshell. All right, so in this diagram, we're going to name a pair of adjacent angles, a pair of complementary angles, and a pair of supplementary angles. So let's do our adjacent angles first. So adjacent, they got to have a shared vertex, a shared side, but no shared interior points. So our adjacent angles are angle D, EG, and angle F, EG. Are adjacent angles. So let's find our complementary angles. So complementary angles add up to 90. So we can eliminate that one right off the bat because it's already bigger. So I've got 28, 72, and 62. 20, 72, and 62. That's 134. That's not a thing. So let's see. 28 plus 72 is going to equal 100. Nope. So 28 plus 62 equals 90. So I've got angle ABC and angle FEG are complementary. Now we need to find our supplementary angles, which need to add up to 180. So two angles that add up to 180, well, 28 and 108 is 136, so 28 is not big enough. So it's 108 plus 62, that's 170. So 108 plus 72 equals 180. So angle HJK and, not plus, and angle FEG are supplementary angles. Supplementary adds up to 180, complementary adds up to 90, and adjacent right next to each other with a shared side and no shared interior angles. All right, so in this one, we've got adjacent angles. We've got to find complementary angles, and we've got to find supplementary angles. So let's go through this again. Adjacent. We share a point. We share a side. We do not share any interior angles or interior points. So angle BAC and angle CAD are adjacent angles. Find our complementary angles, means they got to add up to 90. So we only got 3 to choose from. 127 is going to be out because it's too big. So my guess is it's 37 plus 53. So 7 plus 53 is 60 plus 30 is 90. So those are our 2. So angle BAC and angle RST are complementary angles. And the last one we got to find is our supplementary angles. Well, to get to 180, we're going to need our 127. And 7 plus 7 is 14, so looks like we're going to have 127 plus 53 equals 180. Yes, indeed. So angle CAD and angle RST are supplementary angles. Once again, by keeping it simple, we get to where we're going. All right. So do this next one, pause the video, then start it up and see how you did. All right. So we need adjacent angles, we need complementary angles, and we need supplementary angles. Let's see what we have. So for adjacent, we need a shared point and a shared side, and no shared interior angles. So that is quite clearly going to give us here. So we have angle FGK and angle Notice how we're sharing 2 points in adjacent angles. So these are our adjacent angles. Let's find our complementary angles. Well, complementary means add up to 90. So 131 is going to be out. 49 plus 41 plus 59, 49. 50 plus 40 is 90. So angle FGK and angle GKL are complementary angles. So what about supplementary? Well, here we got 131, which we need. So if I add 41 to 131, I get a number ending in 2. So that's not 180. So what about 131 plus 49? It does equal 180. And these two angles share interior points, but it doesn't matter. They do not have to be adjacent. They can be facing in any direction and still be supplementary. They just have to, their measures just have to add up to 180. So angle GKL and angle HGK are supplementary angles. This next one's kind of interesting. Pause the video, answer the questions, then restart it and we'll see how you did. Okay, our angle KGH here, and angle LKG, adjacent angles. Well, what's the rule for adjacent angles? Got to have a shared side. Well, we got KG in both angles. We got to have a shared vertex. Well, we have K and we have G, so we don't have the same vertex. So the answer is no. No shared vertex. And it has shared interior points. And we got to have, and those both got to be opposite for it to be adjacent angles. So they are not adjacent angles. Okay, let's look at the next one. Our FGK and FGH adjacent angles. Well, we do share a vertex. We do share a side. But if I go and color in FGK, and then I color in the interior of FGH, we do have shared interior points. So no, they are not adjacent. They have shared interior points. We got to have all three circumstances for this to be true. All right, last two. We have a complement and a supplement to find a missing angle. Pause the video, find them, and then we'll move on. All right, so measure of angle 1 plus the measure of angle 2 equals 90. And we know 2 is 5, so the measure of angle 1 plus 5 equals 90. So the measure of angle 1 equals 85 degrees. Then we got a supplement here. So the measure of angle 3 plus the measure of angle 4 equals 180 degrees because they're supplements. And 3 is 148, so we can substitute that in. So then we get the measure of angle 4, and it's all by itself. Then we get the measure of angle 4 equals 32 degrees. And remember, the measure of an angle is a number. If we just have angle, it's a thing. So measures add up to 180. Angles that are supplements are two angles whose measures add up to 180 degrees. All right, this is an interesting one. So LM and PQR are complementary angles. So measure of LMN plus the measure of PQR equals 90. That's the definition of complementary. So when LMN equals 4x minus 2, so let's substitute that in, 4x minus 2 plus PQR, so let's substitute that in, 9x plus 1, that's all going to equal 90. Well, I have x's and numbers on the same side, so I'm going to combine like terms. So 4 plus 9 is 13x, and negative 2 plus 1 is negative 1, equals 90. So I'm going to add 1 to both sides, and we get 13x equals 91. Divide both sides by 13, and x is going to equal 7. So we got to find the measure of both angles. So let's do the measure of angle. We don't like that color. Let's just do blue. So the measure of angle LMN equals 4x minus 2. X is 7, so 4 times 7 minus 2. 4 times 7 is 28. So the measure of angle LMN equals 26 degrees. And the measure of angle, where I used green, the measure of angle PQR is 9x plus 1. X is 7 still, so 9 times 7 plus 1. So the measure of angle PQR equals 64 degrees. And let's do a quick double check. 64 plus 26 equals 90. Hooray, we did it right. All right, so last little bit we're going to do in this section. A linear pair literally means a pair that makes a line. So we need two adjacent angles, and they're a linear pair when their non-common sides are opposite rays, because opposite rays have a common endpoint and form a line. The angles in a linear pair are supplementary angles. So what that means, the measure of angle 1 plus the measure of angle 2 equals 180. Because we know a straight angle measures 180 degrees. So angle 1 and angle 2 are a linear pair. So that's a linear pair. Vertical angles. Two angles are vertical angles when their sides form two pairs of opposite rays. So let's look at angle 3 and angle 4. So their sides form opposite rays. Their sides here form opposite rays. So angle 3 and angle 6, because we did 3 and 6, are vertical angles. So they're across the x from each other. 3 and 6. And then angles 4 and angle 5 are also vertical angles. And we're going to talk a lot more about vertical angles. But for now, focus on being able to identify a linear pair and vertical angles. So let's identify all the linear pairs and all the vertical angles in this diagram. Well, for a linear pair, we have to have a line. We have to have a line. And a pair is 2, so here we have angle 4 and angle 5 are a linear pair. They form a line. Here we got another line. Two angles form a line. So angle 1 and angle 4 are a linear pair. So what about 1, 2, and 3? They form a line, but they're not a pair. So they do not form a linear pair. Now vertical angles. Vertical angles. So here we got two lines that cross and make an X. And 1 and 5 are across the X from each other. So they're vertical angles. Well, what about 2 and 4? Well, not so much, because for 2 and 4 we'd have to have this. And we don't have that. 4 and 3, once again, we would have to have this. And we don't have that. So 4 and 5 are a linear pair. Angles 1 and 4 are a linear pair, because they form different lines. And vertical angles, the only ones that are vertical angles are 1 and 5, because they're the only angles that match each other that are across the X. They're the only ones whose sides form opposite rays. All right, this one we got a little creative. Two angles form a linear pair. So that means their measures add up to 180 degrees. The measure of one angle is 5 times the measure of the other angle. So to find this angle, we need this angle. We don't know what this angle is, so we're going to call this angle X. Well, we know that this is 5 times the measure of this, so that's going to be 5x. And they're a linear pair, so they're supplementary, so it's going to be 5x plus x equals 180 degrees. Combine like terms, divide by 6, and x equals 30 degrees. So this angle down here equals 30. The other one is 5 times 30, or 150 degrees. And we're going to see more, you're going to see problems like this. So when it's 5 times or 2 less than 3 times the measure of something, we first need the something. Often that something is I don't know, and I don't know, we use X usually. So that's how we're going to set these problems up going forward. So take a good look at that and get comfortable with how that wording is. You're going to see more of it. All right, so let's identify all the linear pairs and all the vertical angles in this diagram. And let's start with linear pairs. So let's see. And I like to start at the beginning. So angle 1 and angle 2 are a linear pair. Well, there's another line that angle 1's on. So angle 1 and angle 4. Okay. So I got 1 and 2. I got 1 and 4. Oh, looks like 2 and 3 also make a line. Okay. What about 3 and 8? That's a line, but they're not adjacent. They don't have a common vertex, so they can't be one. So where to next? Well, 5 and 6 form a line. Angle 5 and angle 6. Okay. 5 and 8 form a line. Six and 8 form a line. Well, some of you, I can hear you saying you missed a couple, and we did. We missed angle 4, angle 3, and angle 4. And we missed angle 7 and angle 8. Those are all our vertical or all our linear pairs. So now let's identify our vertical angles. So for vertical angles, their sides have to create opposite rays. So what do we have? We got 1 and 3 go together. 4 and 2 go together. 5 and 7. And then 6 and 8 is going to be our last set of vertical angles. Identifying these will be critical going forward. You're going to see these pop up every so often through the course of our work together. So we are done. Maybe.